Alright, so if while we are in the class, if I fall, it is because I have not cleaned the class and I have a lot of wires around me. So if I trip and fall, that is obvious, okay? Don't worry about it. So what are we going to learn today? We are going to learn about the addition and subtraction of some of the trigonometric identities. What do I mean by that? Let's look at it. If I say sine, we know SOHCAHTOA. I'll not talk about it. But we are talking about, okay, if I have two angles A and B, what is the value of sine A plus B? And there is a formula for that. Similarly, if I have sine A minus B, what is the value of that? Cos A plus B. What is the value of that? Cos A minus B. And you guys must be wondering, why do we need to learn all this? Yeah, and that's a valid reason for confusion or doubt. So here's the thing. If I asked you guys have dealt with a table like this where we have proved in the previous classes, not for you Vedansi, but many of the kids who have attended some of the previous classes. So this is a standard table for 0, 30, 45, 60 and 90. Okay. So sine 0 degree is 0, sine 30 is 1 by 2, sine 45 1 by root 2, sine 60 root 3 by 2, sine 90 1, and cos 0 is 1, root 3 by 2, 1 by root 2, 1 by 2, 0. Then is sine over cos. These are very commonly used angles that we know about. If I say, what is the value of sine 45 degree? You will say, okay, if I know this formula, use A as 45 and B as 30, that makes it sine 75 and I can find it out. Similarly, if I say, what is the value of sine 105 degree? You don't need the log table. You don't need the calculator, you can find it out by yourself. That is what these things help with. Let's say you know value of 45 and 30 degree. I say, what is the value of sine 35 degree, sine 15 degree? So 15 is 45 minus 30. If you have a way to find out that, this relationship or formula, you can derive it. Make sense? Arush? Vedansi, okay? Okay. So, and how these values are derived, I have done that in the previous classes. Ayush has probably heard me or seen me do it. Vedansi, whenever you feel that you would want me to find out how these values are arrived, we can do that in one of the classes, okay? Or else, I will say, I will take some extra money from daddy and then Vedansi can join the SAT class. This is what I had recommended daddy also, that if Vedansi was to join the SAT classes, that gives us more chance actually, more time to interact and more things to learn together. But anyways, let me not do any marketing right now. Let's focus on what we're trying to learn today. Arush, so far okay with me? No complaints, no concerns? You guys are not mad at me because I'm taking classes during Thanksgiving break? Okay. So here's the formula. Sine A plus B equal to sine A cos B plus cos A sine B. Sine A minus B, we'll figure it out. Cos A plus B equal to cos A cos B minus sine A sine B. And we can figure out, if I know this one, I can figure out this one. If I know this one, I can figure out this one. Applying all the understanding. And honestly speaking, I don't remember this formula. I can derive it in 30 seconds, okay? That's why whatever I can derive in 30 seconds, I prefer not to memorize it because my memory cells are almost full. I struggle with my memory, okay? Since my childhood days. Alright, so these are the two formulas I am giving you guys. And you have enough reasons to say, you are saying that you cannot rely on your memory. Why are you forcing us to rely on our memories? Right? So these are the formulas. Sine A plus B equal to sine A cos B plus cos A sine B. cos A plus B equal to cos A cos B minus sin A sin B. Okay, this is the formula which we will use. But before we start using it, we want to believe it, and we will prove it today. Okay? Yep. Have you guys known about this before, or this is going to be a new thing? Wonderful. That makes me super happy. So, and see now here the table that I was showing you guys. If let's say I'm trying to find out value of sine 15 degree. Sine 15 degree will be sine 45, okay, sine 45 minus sine 30. And once we have the formula, we can plug that in, which will be something. Let's say if I'm trying to find out sine of 105 degrees, so sine 105 will be 60 plus 45, right? So that means I need to know sine 60, cos 45, cos 60, sine 45, and all that was there in the table, okay? So we'll come back to the table. But let's first try proving this formula. Sin A plus B equal to sin A cos B plus cos A sin B. And let's see if this formula has enough merit to do it. Okay. Ready? Okay. Let's say there are two angles A and B. And we are trying to find out what is the sine of A plus B. So, let's make an angle A. I've just made an angle A, okay? Now, on this line, I'm making angle B. This angle here to here is B. Let me mark a place on this line where it is 1 unit, meaning here to here it is 1. So this length of this line segment that you see is 1 unit. From there, I am dropping a perpendicular onto this line. So this is a right angle triangle right now. The one at the top is a right angle triangle. Yeah. From here, let me drop another perpendicular. So this is also 90 degree. So now we are dealing with two right angle triangles. One is rising on the top of this guy. Yeah. This is 1. How much would be this length? Applying SOHCAHTOA. You are looking at this triangle at the top. This is the hypotenuse of this right angle triangle. This is the side opposite to this angle. Yeah. So let's say this is x. So applying SOHCAHTOA, x over 1 would be sine of b. Correct? Sine of b. Is that okay so far? Are you okay? So I will replace x with the sine of b. I'm still looking at the top triangle, okay? How much would be this length? Now let's say this is x, okay? I'm just giving it a name and then deriving it, okay? So x over 1 would be what? Cos of b? Yeah? No? I'm looking at this triangle, okay? This side we found this is sine of b. This side I'm trying to find out. Because only thing that we know is this side, which is 1, okay? So x over 1 would be cos of b, or cos of this angle would be adjacent side by hypotenuse. That is x over 1. That means in this case this x is equal to cos of b. Let me know if I am forcing you guys to believe something. So this side is cos of b. So far okay? I'll give you guys 5 seconds to process this. Yeah. So we took this right angle triangle. Basically, we made this angle A, and then on this line we made angle B, and on this line we marked a length of 1, and from that point we dropped a perpendicular onto this line. So this became a right angle triangle, and on this point, from this point we dropped a perpendicular onto this line. So we have two right angle triangles, this one and this one. We are starting from this side. And why we are starting from this side? Because we had one side known and the angle known. We are using that information to find out the length of this side and this side. Yeah? Okay. Now, moving on. So, just give me a second. I'm checking if the video is recording correctly or not. Alright, yeah. So, here, we have figured out length of this side and this side. Now, come back to the table, triangle below. On this triangle, now I know this side and I have this angle. We'll use this information to find out this side and this side. Now, same thing. If this is, let's say, x. So, here I'm looking at angle A. So, sine of A would be opposite side by hypotenuse. Opposite side is my x, which we are trying to find out. And the hypotenuse is cos of B. Yeah? So this length x became sine of A times cos of B. Is that okay? Sure? 100%? Okay. I hope nobody, I hope some of you have watched Kaun Banega Crorepati, KBC. Amitabh Bachchan says lock kar diya jaye, so I'm locking it. So this part is okay. So this x, this length we found as this thing, sine of A times cos of B. Yeah? Look at the journey. This is 1, this is angle B. Sine of B is this side by this, so this side is equal to sine of B. This side became cos of B. Cos of this angle would be this side by 1. So this side is equal to cos of B. We use this side's length as cos of B and try to find out this length, which is sine of A times cos of B. Yeah? So now you guys will start thinking. We are seeing something here, sine of A cos of B. We found something. Something, part of the formula. Ultimately, if I delete this is cos of B, okay? I'm just writing it here so that I have some more space. Now if I come back to this triangle, if I'm dropping a perpendicular from this point onto this side, I have this triangle here, the larger triangle which has the angles A and B together. Yeah? So if this whole length, let me use a different color for you guys to be able to relate to it. Man, I thought this will look blue. This looks like black only. I'll use this one. Yeah, this is better. If I'm trying to find out the length of this green line or line segment, whatever you call it, this is part of this right angle triangle which has angle A plus B. Yeah. If this green line is, let's say, x. If this green line is x, I know I'm using x for everything that is not known, okay? So, if this green line is x, this whole angle here to here in this triangle, larger triangle, this is A plus B. So, x over 1 would be equal to sine of A plus B. Yeah? This whole thing is sine of A plus B. So if we figure out how much is this total length, then we'll get the formula for this guy. Correct? We are trying to find out this total length. Arush, are you with me so far? Vedant, you okay? Alright. So we found this whole length here to here is sine A plus B. Okay? Now I want to break it down. Because I know part of this length. Let's drop a perpendicular from here to here. We know this length. If we could figure out this length, that will be my total length. Green one. Yeah? We are trying to find out the length of this side. which is equal to sine of a plus b. Correct? Yeah? Yes or no? I'm not getting you guys confused, right? Stop me from getting confused. So I'm looking at the larger triangle which has this angle as a plus b. So we said, okay, sine of a plus b equal to this length divided by 1. So this length, this whole length, the length of this whole green line segment is equal to sine of a plus b. I'll write it down so that we have no confusion. Now this whole length x can be split into two parts. This length plus this length. Correct? This length we already know. This is equal to sine a cos b. That we derived a little while ago. Yeah? Now, let's look at this line and this line. Let's find out. So now we are coming to this shaded triangle, okay? Okay? And from this shaded triangle, we need to find out this length. Yeah? Because we know this part already, which is sine a cos b. Yeah? Now, this triangle we can deal with provided we use some of the information that we have. Let's look at the angles for this guy. Okay? Now, look at this side, this line and this line. These two are parallel lines. And this is a third line intersecting both of them. Correct? If this is A, this angle will be A here. Yeah? The tiny triangle, the angle that you see in the middle. How about this guy? This whole thing is 90 degree because it's a perpendicular line. So this angle is 90 degree minus A. Yeah? If this angle is 90 degree minus A, this one is going to be A only. Because sum of these two angles will be 90 degree. That is how this 90 plus 90, 180. Sure? Okay. So look at it. So coming back to this one, we were trying to find out this length. This length, we know part of it. So from this point, we dropped a perpendicular, which created this smaller right angle triangle. And if we have to find out this whole length, we know this length already, sine a cos b. We are trying to find out this length. So this length we are trying to find from this triangle, and hence we are trying to derive the value of the angles. This line parallel. These are opposite internal angles. So this is A, this is A. This whole thing is 90 degrees, so this will be 90 degree minus A, and hence this angle will be A. So far okay? Angle part is okay. Now if you have a triangle where the angle is known and this side is known, correct? You can derive other sides. Now look at this one. If I have this my angle and I am trying to find out this one, so this is my adjacent side, this is my hypotenuse. Hypotenuse is known, adjacent side is what we are trying to figure out. I will give this guy a name y, okay? We already have an x here, okay? So this y over hypotenuse, adjacent side over hypotenuse will be equal to cos of a. Y over hypotenuse will be equal to cos of a. Now let me write it the other way around so that it doesn't bother you guys. If I have this angle A known to me, cos of A would be the adjacent side by hypotenuse. Will be equal to adjacent side, which is y, over hypotenuse, which is sine of b. That means this y is equal to sine of b times cos of a. Time for dancing song. Sure, right? Everybody okay? So we found this length as sine of b cos of a. This length we found as sine of a cos of b. If I have to find out this whole length x, that will be equal to y plus sine of b cos of a. And this y we found here, which is sine of b cos of a. Sine of b cos of a. So this y is this, and what am I writing here? This part is sine of a cos of b. Cos of b. So this whole length is this length y plus this length. This length is sine of a cos of b. Sine of a cos of b. Yeah. And this y is nothing but we found out from here it is cos of a sine of b. Cos of a sine of b. So this one is, and this x, as we know, it's equal to sine of a plus b. So let's see again, a lot of sines cos to get you guys confused, but let's not worry about it. Let's look at the journey, how we have traversed from here to here. Okay, we took a line and made an angle A. Okay, and on the top of this line we made angle B. So this is the line which is making angle B with this line, which I deleted by mistake. And we cut a length of 1 unit on this line. Wherever it is 1 unit, from there we drop the perpendicular onto this line, so this became a triangle, right angle triangle. And from this point where it made 90 degree, we dropped another perpendicular to this line. So we have two right angle triangles. We started with this right angle triangle. If this is angle B and this side is known as 1, so sine of B equal to this side by 1. Sine of B equal to this side by 1. So this side is equal to sine of B. We found this side. Similarly, we found this side equal to cos of B. Right? So we found this side is sine of B, this side is cos of B. Now we took this information, came to this triangle. This is angle A known to us. So this side will be equal to, so sine of this angle would be opposite side divided by cos of B. So from that we found sine of A equals this side by cos of B, and hence we found this length equals sine of A cos of B. Yeah. So we found this length. Our goal was to find out sine of A plus B. So we came to this triangle, the larger triangle, and dropped the perpendicular from here to here. This whole angle from here to here that you see is A plus B. So sine of A plus B would be this side divided by hypotenuse, which is 1. So sine of A plus B is equal to this side. This side we had a problem that we only knew part of this length, which is sine of A cos of B. So we had to find out this length. So to find out this length, what we did was we dropped the perpendicular so that this part is known and this part is to be figured out. And then we looked at this side and this line and this line, which are parallel to each other. So these are opposite internal angles. We found this angle is A. So when this angle is A, if you have to find out this side, so we'll use the SOHCAHTOA for cos of A. So this side by hypotenuse is cos of A. So from that we found this side equal to cos of A times sine of B, because this side is sine of B. So we found this thing. So now we know this length and we know this length. We are just adding these two lengths, which will give me this total length, which is equal to sine of A plus B. Yeah. So from that the formula came as sine of A plus B equal to sine of A cos of B plus cos of A sine of B.
Would this only work for like unit circle or was it?
Any circle. It's a generic rule. See, I have not drawn a unit circle yet. There is no relevance of unit circle. We just use this information as a side known to us to be able to derive everything else. I did not even utter the word unit circle. Yeah? So that means this is a generic rule. If you know two of the angles, you can find out sine of A as a sum of the two angles. Okay? So sine of A plus B equals sine of A cos B plus cos of A sine B. You are flipping it actually. Sine of A cos of B, then you are flipping the angles for sine and cos both in the second one. Yeah? Everybody okay? Tired? Exhausted? Yes or no? No? Exhausted? No? Yes? Okay. Alright. So, that's a problem with people who deal with math, okay? Sometimes they behave weird. I had one of my uncle. He was a great mathematician. I'm probably not even 0.0005% of him. His name was Arun Lal. He has written multiple books on maths actually. So and he used to conduct math Olympiad and all. A lot of fancy stuff. Okay, I have never gotten even anywhere close to him. But since he was a hardcore mathematician, he will always be lost in math. I have seen him wearing a V-neck sweater where the V is on the back. People are so very lost in math, they will not even imagine what is happening around them. Okay, I have seen, V-neck sweater, right? Your V is on the front. I have seen him wearing the V-neck sweater where the V is on the back. He's always lost with math. Okay, so I'm trying to avoid not to get to that situation, but I might behave weird at times. Okay, so bear with me. All right, so I hope my uncle doesn't feel bad about it. He's no more. He must be watching me do all the nonsense here. Okay, so we found that this formula we can believe hereafter. Yeah. Now let's talk about what will happen if I know A and B and I'm trying to find out sign of A minus B. And you guys must be scared that, oh man, this guy is going to take another 15 minutes to prove this or find it out. Answer is no. We will use some of our understanding of the unit circle to use this. Okay. Now, A minus B. Can I say A minus B is nothing but A plus minus B? Is that okay? So instead of having two angles A and B, I have two angles A and minus B. What does it mean to us? If I'm talking about angle A, I'm talking about this. If I'm talking about, meaning I'm going in the anti-clockwise direction. If I'm talking about angle minus A, same value but I'm going in a clockwise direction. That's the difference, correct? So here I have two angles. I'm adding the two angles. I'll use the same formula, but we will come back to this concept, okay? This concept of positive angle and negative angle, okay? Yeah? So, I can say, let me create some space here. So, sine of A minus B is nothing but sine of A plus minus B. Okay? I'm adding two angles. So I'll use the same formula. And that becomes sine of the first angle times cos of the second angle, which is minus B, plus cos of the first angle times sine of the second angle, which is minus B. So far, nothing bothering you guys? Now, coming back to unit circle. To be able to visualize these things. If I'm talking about, let's say we are dealing with minus B, right? Let's say this is my angle B. This is my angle B. And I'm making the other angle minus B. Okay? When I'm talking about angle B, what will be the coordinates of this point? Cos of B, comma sine of B. Correct? When I'm talking about angle minus B, what will be the coordinate of this point? Cos of minus B, comma sine of minus B. Correct? Basic unit circle concepts. What is my x coordinate? Cos of B and cos of minus B. Oh, my x coordinate will be the same no matter whether I'm doing first quadrant or fourth quadrant. That means my cos of B and cos of minus B are same. I can replace wherever I have a cos of minus B with a cos of B. Both are same. My x coordinates are same. Sure? Convinced? Worth locking? Okay. So here I had a cos of minus B. I will replace that with cos of B. Okay? Because there's no point dealing with minus angle, plus angle. This gets confusing, right? You're not wanting that. Oh, your table lamp is about to fall. Was about to fall, okay. Alright, so coming back to sine part of it. What is my sine? This is my y coordinate. When I have angle of B, my y coordinate is positive. When I have angle minus B, my y coordinate is negative. Again, when I had angle B, my y coordinate was positive. When I am talking about angle minus B, my y coordinate became negative. Sure? That means I can say sine of minus B is equal to minus sine of B. Is that okay? Arush, I'm not forcing you to believe this, right? You agree? Okay. Alright. And we saw that my x coordinate doesn't matter. Yeah? B or minus B. Again, take a picture of this in your mind. Plus angle B, angle minus B. Angle B, x and y coordinates are this. Angle minus B, x and y coordinates are this. So my x coordinate will be the same. These are two right angle triangles that are getting created as a replica, a mirror image of each other. Right? We are just flipping it down. So my x coordinate value will be the same, positive. So cos of B and cos of minus B are same. That's what we are writing here. But my y coordinate flips from positive to negative. That's why I have written it down here. Now, we can get rid of the negative angle that we see here. Sine of A times cos of minus B. Cos of minus B same as cos of B. I'll replace it with this guy. Plus cos of A sine of minus B. Sine of minus B is equal to minus sine of B. So this is minus sine of B. So when I rewrite this equation, this becomes sine of A cos of B minus into plus minus cos of A sine of B. You're not seeing it a V-neck sweater with the V in the back, right? So far. Okay. What I'm trying to say is it making sense to you all? You both, at least. Okay? Net, first formula that we learned or we started believing in was sine of A plus B equal to sine of A cos B plus cos of A sine B by drawing those two right angle triangles sitting on the top of each other. And then, not top of each other, one sitting on the top of the other one. And we did not want to draw the same picture, we just used this understanding that if I have A plus B, that is equal to A plus minus of B. And then we replaced B with a minus B in this whole thing. And then we are trying to come back to this concept of unit circle to relate what is happening with x and y coordinates in both the angles. And from that we found that sine of minus B is equal to minus times sine of B, and cos of minus B doesn't matter actually, it's the same. Yeah? So far we have looked at two formulas. And I'm assuming that both my kids are having zero concerns with respect to these two formulas because we saw why it is to be believed. Yeah. So first formula was sine of A plus B equals sine of A cos B plus cos of A sine B. Okay. Second formula, which was an extension of this thing using a unit circle concept. Sine of A minus B became sine of A cos B minus cos of A sine B. No negative angles. Yeah? Now we are going to the next formula, which is cos of A plus B. Good that I have already bothered you guys with that diagram. We'll leverage the same diagram. This is my angle A I made an angle B on the top of this line, so this angle is B, and I cut a length of 1 unit, and wherever that is, from there I draw the perpendicular to this line, and from this point I draw the perpendicular to this line. Same situation like before. Now if this is 1, if I am looking at this B, cos of B, cos of B would be this side by 1. So let's say this is X and this is Y. I will not use the same name so that way it doesn't get confusing. I will write Y here and X here. So this Y over 1, cos of B equal to Y over 1. So cos of B equal to Y. So this is equal to cos of B. Okay. Similarly, X over 1 is your sine of B. So sine of B equal to X by hypotenuse, that is X. So this is equal to sine of B. Yeah. So this length is cos of B, this is sine of B. Now we are coming back to the same this triangle, the smaller the one at the bottom. So here this length is cos of B. Let's say this is K and this is L. So sine of A would be equal to K over cos of B. That means K equals sine of A cos B. And then here this L over cos of B is equal to sine of, L over cos of B is equal to cos of A. So we are trying to find out sine of A equal to this length by this length, hypotenuse. Cos of A equal to this length by this length. Correct? So from this we found this L equal to cos of A times cos of B. Yeah? This whole length. Yeah? Now if I drop a perpendicular from here to here, because we are trying to find out what? Cos of A plus B, meaning cos of this complete angle. So I will make this line again green so that it is visible here. Draw the perpendicular, so this green triangle, okay? We are trying to find out this length. Okay, so this is the triangle that we are dealing with. Now, what we have found is this whole length is cos of A plus B. Cos of A cos B. Cos of A times cos of B. So far okay, right? See, I have done boring stuff since beginning. This is what you guys have done in the previous proof, okay? So I'm just continuing with that. So we found this length. What we have to find is cos of A plus B. So here, let's say this length is M. I'm looking at the green triangle right now, okay? So cos of A plus B would be equal to this length M divided by hypotenuse, which is 1. That means this length would be cos of A plus B. But right now we have a problem of surplus. We wanted this length, we got more than this. So if I have to find out this length, I have to take this length minus this length. Let's say this is U, or let's say this is Y. No, Y we have already used. Let's say this is U. Okay? So this length N would be equal to this whole thing length L minus U. L we know is cos of A times cos of B minus something. Okay? Now what is this length? For this length again we have to lean on this triangle. We drop the perpendicular from this point here. Okay? And we have to find out this length this time. Okay? So that this length will be equal to this. So from this whole length we will subtract this one to get this one. Correct? Now coming back to this triangle, now you know this is A, and this is also A. that we saw a little while ago. Now this is angle A, this side is sine of B. So we have to find out this one. So this is angle A, this is the opposite side by hypotenuse. So sine of A in this tiny triangle is equal to this side that we are trying to find out, which is U, divided by hypotenuse, which is sine of B. So that means U equals sine of A times sine of B. So if you have to find out this length M, we know M equals whole length minus this length. Whole length is cos of A, cos of B. Let me go step by step. So that is L, the whole length, minus U. What is the L? L is cos of A times cos of B. Minus U, we got as sine of A, sine of B. Yeah. So this M is nothing but your cos of A plus B. So you will replace M with the cos of A plus B. This equals cos of A times cos of B minus sine of A times sine of B. Look at the whole journey. This is a one-time picture that you have to store in your memory. This picture. You took an angle A, on the top of that you drew angle B, you cut a length of 1, from there you dropped a perpendicular to make this triangle, then from there you dropped a perpendicular to make this right angle triangle. Now since you know this side, you found out this length and this length. Use this length, come to this triangle, find out this length and this length. Since we are talking about cos, see the only difference between sine of A plus B and cos of A plus B, when you look at sine of A plus B, we were looking at the angle, the side opposite to the angle, which is the vertical length. When you are talking about cos of A plus B, we are looking at the horizontal length. That's the only difference. Method for proving it remains the same, no difference. You have to find out this length, you found this length plus this length. You came back to this triangle. You found out this length and added this length, you got this one, which is equal to sine of A plus B. When you look at cos of A plus B, you again came back to this triangle because here you knew the whole length and you have to subtract this length to find out this length, which is equal to cos of A plus B. Same method, same problem, same approach. In case of sine, you are looking at the vertical length to derive it. In case of cos, you are looking at the horizontal length. Sure? Everybody clear? 100%? Okay. So that derives our conclusion on this one. So which says, this formula also we can trust. That means there is a third formula that is in our weaponry that we can use hereafter, which says cos of A plus B equals cos of A cos of B minus sine of A sine of B. Okay. Now, what will happen if I am talking about cos of A minus B? Same approach. A minus B is nothing but A plus minus B. So this will be equal to cos of A plus minus B. And hence it will be, I will replace every B with a minus B and C. Cos of A times cos of B, cos of minus B, minus sine of A times sine of minus B. And if you guys recollect what we did 5-10 minutes ago, cos of B and cos of minus B doesn't make a difference. We are looking at the x component. Yeah, x coordinate. Sine of minus B is opposite of sine of B in terms of sine. So we'll replace cos of minus B with the cos of B and sine of minus B with the minus sine of B. Yeah. So this becomes cos of A, just for you guys to recollect. Cos of minus B is equal to cos of B, and we saw sine of minus B is equal to minus sine of B. We'll just replace this in this equation. This became cos of A times cos of B minus sine of A times minus sine of B. So this minus and minus will come together and become a plus. So it becomes cos of A times cos of B plus sine of A sine of B. Yeah. So we have other formula to our disposal that we can use anytime. That is this one. Cos of A minus B equals cos of A times cos of B plus sine of A sine of B. And that's the reason why when I started talking about it, I told you this formula and I told you this formula. These two I did not bother to tell you because this is something that we can derive. It's not that difficult. I didn't want to mess up with the formula. But I knew this. I mean, I was just holding it so that you guys don't get overwhelmed by seeing 4 formulas in one go and then struggling to figure out how do I convince myself around this one. Now, you guys will not have to prove any of the formula in your exam. This formula becomes your, what you call, defense mechanism or your tool for dealing with it. Now let's see if I say cos of 60 degree equal to 1 by 2. I'm not saying it, this is a value, we can prove it also, okay? But if we know cos of 60 is 1 by 2, we can find out the value of cos of 120, cos of 240, cos of 480 also without worrying about it. And you will say how? Cos, see my A and B, I can replace it with 60 and 60. My A and B both can be 60. So cos of 120 would be cos of 60 plus 60. Both my angles are same. So that will be cos of 60 times cos of 60 minus sine of 60 times sine of 60. So, or look at it. If I say cos of 2a will be equal to, again I am talking about cos of a plus a. Cos of a times cos of a minus sine of a times sine of a. Because 2a is a plus a. If you have to find out cos of 5a, this is equal to cos 3a plus 2a. You can break it down. Yeah? So this helps you derive value for different angles. Okay? Without dealing with a calculator. You guys are blessed. You have calculator even in 10th grade. The first time I interacted with a calculator was when I cleared my entrance exam and went to the engineering college. And that was like a privilege. Oh, I have a calculator now. But no, again, no, nothing right or wrong. Here, this is how the whole course structure is defined. For us, it was a little different. I'm talking about ancient times, right? I mean, obviously, calculator was probably invented, but had not reached to the masses. But these are the things that gives us the ability to deal with different situations, different problems. Okay. Is this something interesting that we learned today or okay? Was this interesting or difficult? Vedansi is talking to the mute button, I cannot hear it.
It's not difficult.
It's not difficult, but was it something that really creates that excitement that yes, something new, something interesting?
It is something new.
Yeah.
I would describe it as like a very interesting.
Okay. No, that's fine. So basically something new that we learn, and the excitement will come from the fact that when we practice it. Okay. So that's what we'll lean on. Okay. What I suggest you guys is whenever we learn something, go to Khan Academy, pick up that same unit, try doing the unit test and see if this knowledge, this information is helping you do that. Okay? Now if somebody says, okay, find out the value of sine of 15 degree. You would not go hunting for a calculator. Sine of 15 degree, okay, sine of 15 is nothing but sine of 45 minus 30 degree. Do I know the value of 45 and 30 degrees? Sine and cos. Okay, 35, 45 and 30. Okay, so it is sine A minus B. Oh, I'll lean on this formula. Sine of A cos B minus cos of A sine B. Here my A is 45, B is 30. A is 45, B is 30. Do I know all these values? I'll just plug it in. Done. And the catch here is, right? I mean, you guys have a little different approach. You might not get enough opportunity to practice problems, but I still keep insisting that no, get your hands dirty. And I'm not kidding. See. Yeah, see. I have to literally go wash my hands before I can even dare to have my tea. But the fact is, say, math is all about getting our hands dirty, okay? That would make the difference. That would build that confidence. That will give us that ability to narrate story around the topic that we learn. Well, that's a good speech. Alright, so I'll let you guys go. Unless you have any doubt, Arus, Vedansi, feel free to ask questions. Comfortable? Very comfortable? Next Sunday, I might skip the class, okay? Because of Thanksgiving break. Actually, my daughter has come back from college and Sundays when she is going back. So, we'll probably be busy making arrangements for her travel. So, this week, we have classes till Monday. Monday, as in, I have some algebra 2 and kids, classes for the younger toddlers, actually, the kids who have just left diapers. So, they come to my classes for learning tables and all that, okay? So, Monday, algebra 2 and this one class will be there. Tuesday onwards, we are taking a break. I mean, I'm taking a break. I'm letting you guys also enjoy the break of Thanksgiving. And then we'll resume our classes from next week. So, that's the plan. Okay? So, enjoy your Thanksgiving. Do as much practice you can. All the Arus, you are anyways with me for the SAT class today. So, see you in the SAT class. Alright? Have fun, kids. Bye-bye.
Bye.
Bye-bye.